find a power series representation of, and the function we're going to have is x cubed over x plus 2. So let's think about the terms that appear in a power series. When we did the last couple problems ago, when we were looking at the graphing program, all of the terms in a power series are polynomial terms. They're x to a power. So if I look at this in the numerator, I have x cubed, which is also a polynomial term. It's x to a power. And so what I can do is I can take and pull that x cubed out in front. And what I can do is find now just the power series of 1 over x plus 2, write that, and then I'm going to multiply it by x cubed. Because all that's going to do is shift all my powers up by 3. I still am left with polynomial terms, which is what I need for a power series. And we already found this in the last example, 1 over x plus 2. We've already done that. So we can plug in now what we know from the last example. So this was x cubed times the sum. It was negative x to the n over 2 to the n plus 1. We need to move the x cubed inside, so I'm going to do that. X cubed, negative x to the n. And if you're writing down a power series, you should only have one term that has x in it, x to a power. So I need to combine this x cubed and this negative x to the n. Can you combine those? These are exponents. What's my base for the first one? The base is x. For the second one, what's my base? Negative x. Are those the same thing? No. So I can't just shove them together and combine them because they're not the same. But I need to combine them. So in order to do that, I'm going to have to rewrite negative x to the n. We kind of did that earlier, where I rewrote that as negative 1 times x. N equals 0 to infinity, x cubed. I can rewrite this as negative 1 to the n, x to the n. And I can now if I look at my two bases for my exponents, let me circle them in blue so we can see this one and this one. They now both have a base of x. So now that they have the same bases, we can shove them together, add their powers, and so I get n plus 3 for my new exponent. Okay, so it looks like sum n equals 0 to infinity, negative 1 to the n, x to the n plus 3 over 2 to the n plus 1. And this would be your power series representation. Okay. Again, I didn't ask for interval of convergence, but what if I did? Let's look back at what we did. We used what we did in the previous problem to write the power series here. So to figure out the interval of convergence, we need to know what the interval of convergence for the last problem was. So does someone want to tell me what was our interval of convergence for the last problem? -2 to 2. My answer is completely based on this previous answer. So the power series at the end here has to have the same interval of convergence as the one we used. So the interval of convergence of this one is the same thing, -2 to 2.